Tonight, we're diving beneath the surface of Earth to explore the hidden mysteries of volcanoes. From ancient eruptions and glowing lava fields to supervolcanoes and strange volcanic worlds beyond Earth. Before we begin, leave a comment telling me what city you're watching from tonight, and if you could safely witness any volcano in history, which one would you choose? And if you enjoy relaxing cinematic documentaries like this, don't forget to subscribe, get comfortable, and let's slowly drift into the hidden world of volcanoes tonight. Thousands of years before modern geology existed, people living near volcanoes already feared something they could not fully explain. The ground beneath them did not always feel stable. Sometimes the earth trembled softly in the middle of the night. Sometimes steam escaped from cracks in the hillsides. Sometimes lakes suddenly became warm without warning. And sometimes entire mountains exploded with enough force to erase forests, villages, and even coastlines within hours. To ancient civilizations, volcanoes often felt supernatural. But what makes volcanoes truly unsettling is not only what happens above the surface, it is what exists far below it. Because the first secret hidden beneath volcanoes is that Earth itself is not nearly as solid as it appears. From space, the planet looks calm and stable. Oceans move slowly. Continents appear fixed in place. Mountain ranges seem eternal. Yet deep beneath the surface, Earth is constantly moving, reshaping, recycling, and releasing heat that has existed since the birth of the planet more than 4 billion years ago. And volcanoes are one of the few moments when humans briefly witness that hidden world escaping upward. The second secret is that the inside of Earth is not one giant ocean of lava like many people imagine. Most of the planet's mantle is technically solid rock, but under enormous heat and pressure, that rock behaves differently over long periods of time. Instead of remaining completely rigid, parts of the mantle slowly flow, almost like an incredibly thick liquid moving over millions of years. Scientists compare it less to water and more to warm wax, slowly deforming under pressure. That movement may seem insignificant on a human timescale, but over geological ages, it becomes powerful enough to move continents themselves. And that leads directly to the third secret. The continents beneath human civilization are drifting all the time. North America is slowly separating from Europe. The Pacific Ocean is changing shape year by year. Entire sections of Earth's crust slide, collide, split apart, and sink back into the planet at speeds humans barely notice during a single lifetime. Volcanoes often form near these massive tectonic boundaries. Around the Pacific Ocean, this creates the Ring of Fire, one of the most volcanically active regions on Earth. Japan, Indonesia, Alaska, Chile, and the western coast of North America all sit near parts of this enormous system. And what makes the Ring of Fire so unsettling is its scale. It stretches across thousands of miles, surrounding much of the Pacific like a scar running around the planet itself. But even tectonic plates are only part of the story, because the fourth secret is that some volcanoes should not exist where they are. Hawaii is one of the most famous examples. The islands sit far from major tectonic plate boundaries, yet enormous volcanoes continue forming there. Many geologists believe Hawaii exists above a mantle plume, sometimes called a hotspot, where unusually hot material rises upward from deep within Earth. As the Pacific Plate slowly moves across this hotspot, new volcanoes form while older islands drift away. But scientists still debate how deep these plumes truly extend, and whether all hotspots behave the same way. In other words, even now, parts of Earth's volcanic engine remain uncertain. And uncertainty becomes even stranger when people realize the fifth secret. Humans have never actually reached the mantle itself. The deepest hole ever drilled into Earth, the Kola Super Deep borehole in Russia, descended about 12 kilometers before temperatures and pressure became too extreme for equipment to continue. That sounds deep, until you realize Earth's radius stretches more than 6,000 kilometers toward the core. Human beings have explored more of the moon's surface than Earth's deep interior. Almost everything scientists know about the inside of the planet comes indirectly through seismic waves, earthquake data, laboratory simulations, and mineral evidence carried upward by volcanic activity itself. In many ways, volcanology is partly the science of interpreting clues from a world humans cannot directly see. And those clues reveal the sixth secret. Most magma never reaches the surface. People often picture giant chambers of molten lava sitting beneath volcanoes, waiting to erupt at any moment. But reality appears far more complex. Many volcanic systems contain networks of smaller reservoirs, fractures, and partially molten regions spread throughout the crust. Some magma cools underground before eruption ever happens. Some becomes trapped permanently beneath mountains. Some may slowly crystallize into granite deep below the surface, becoming part of future continents long after the volcanic system itself disappears. That means entire hidden volcanic worlds may exist underground without humans ever witnessing them directly. And sometimes those underground systems grow to astonishing sizes. Which brings us to the seventh secret. Some of the most dangerous volcanoes on Earth do not even look like volcanoes anymore. Yellowstone is one example. Many visitors imagine they are entering a normal national park filled with forests, rivers, and wildlife. But beneath Yellowstone lies one of the largest volcanic systems on Earth. The visible landscape above is actually part of an enormous caldera formed by ancient eruptions so powerful they reshaped entire regions. The same pattern exists elsewhere. Some volcanic systems remain hidden beneath valleys, lakes, forests, or even cities. Others no longer form dramatic mountain cones because earlier eruptions already collapsed them long ago. In some cases, the absence of a visible volcano can create a false sense of safety. And perhaps that connects to the eighth secret. Earth's crust is shockingly thin. Compared to the size of the planet, the crust resembles something closer to a fragile shell than a massive protective layer. Beneath some ocean floors, it may be only a few miles thick. Below that thin crust lies enough heat and pressure to continuously recycle sections of the planet over millions of years. Ocean floors sink back into the mantle through subduction. New crust forms along mid-ocean ridges. Mountains rise and erode away. Entire landscapes disappear and reform repeatedly across geological time. Volcanoes are simply moments where those deeper planetary processes briefly become visible. And those processes may still be fueled by another hidden force. The ninth secret is that part of Earth's internal heat may come from radioactive decay happening naturally inside the planet. Certain unstable elements buried deep underground slowly release energy over immense spans of time. That heat contributes to keeping Earth geologically active even billions of years after its formation. Without enough internal heat, plate tectonics might weaken or stop entirely. And if tectonic activity stopped, Earth itself could become a very different world. Some scientists believe this may partially explain why smaller planets like Mars became far less geologically active over time. Mars still contains giant volcanoes, including Olympus Mons, the largest volcano in the solar system, but much of the planet appears far quieter today than Earth, which creates a strange possibility. Volcanoes may actually be signs that a planet is still alive. And that idea leads to the final secret hidden beneath volcanoes. The planet beneath human civilization has never truly been still. Cities rise, believing the landscape around them is permanent. Roads, towers, ports, and entire civilizations are built with the assumption that the ground below will remain stable indefinitely. But volcanoes quietly remind humanity that Earth operates on timescales far older and far larger than civilization itself. A mountain can sleep for centuries before erupting again. A magma system can slowly expand underground without visible signs for generations. A coastline can change shape over geological time while humans barely notice it happening. Even now, beneath oceans, forests, deserts, and crowded modern cities, Earth continues moving in silence. Heat rises upward from deep below the crust. Pressure slowly builds. Rock bends, fractures, and shifts. And somewhere beneath the surface tonight, magma may already be traveling toward a place where the planet will eventually open again. If volcanoes are the visible wounds on the surface of Earth, then magma is the hidden force moving beneath them long before any eruption begins. Most people imagine magma as simple underground lava, glowing liquid rock waiting beneath mountains like water trapped behind a dam. But the deeper scientists study volcanic systems, the stranger magma becomes. Because the first secret about magma is that magma and lava are not actually the same thing. The word magma refers to molten rock still trapped beneath Earth's surface. Lava is what that material becomes only after it finally erupts into open air. That difference may sound small, but it changes everything about how volcanoes behave. Deep underground, magma exists under enormous pressure. Gases remain trapped inside it. Temperatures stay extremely high. Minerals continue melting, crystallizing, and mixing together in ways humans still do not completely understand. The moment magma reaches the surface, pressure drops rapidly. Gases escape violently. The material begins cooling almost immediately. And suddenly, the underground world, hidden for thousands of years, becomes visible for only a brief moment before hardening back into stone. In some ways, lava flows are less like rivers and more like temporary glimpses into Earth's interior. And what makes them even stranger is the second secret. Not all magma looks or behaves the same way. Some magma is thin and fluid, capable of flowing across entire landscapes for miles. Other magma is thick, sticky, and barely moves at all. That difference often determines whether a volcano quietly pours lava down its slopes or explodes with catastrophic force. One of the main reasons involves silica. Magma rich in silica tends to trap gas more effectively because it becomes thicker and more resistant to flow. Over time, pressure builds underground until the system can no longer contain it. When eruption finally happens, the result may look less like flowing lava and more like the mountain itself detonating. Lower silica magma behaves differently. Basaltic lava, like much of what erupts in Hawaii, can remain fluid enough to travel long distances in glowing rivers of molten rock. And this leads directly to the third secret. The most dangerous part of a volcanic eruption is often not the lava itself. Hollywood frequently shows people outrunning fast-moving lava rivers, but in reality, many lava flows move slowly enough for humans to escape on foot. The true danger often comes from pyroclastic flows, toxic gases, collapsing ash columns, or explosive pressure waves. Pyroclastic flows are among the deadliest phenomena on Earth. They are superheated avalanches of gas, ash, rock fragments, and volcanic debris racing downhill at terrifying speeds. Temperatures inside them can exceed several hundred degrees Celsius, hot enough to instantly ignite forests and destroy nearly everything in their path. When Mount Vesuvius destroyed Pompeii in 79 AD, many researchers now believe large numbers of victims may have died not from lava, but from these extreme surges of heat and ash, which reveals something unsettling about volcanoes. Sometimes the deadliest forces are nearly invisible until they arrive. And invisibility becomes even more important with the fourth secret. Magma contains enormous amounts of dissolved gas. Deep underground, pressure keeps those gases compressed inside molten rock, almost the way carbon dioxide stays trapped inside a sealed soda bottle. But as magma rises toward the surface, pressure decreases. Gas begins expanding rapidly. If magma is fluid enough, those gases escape gradually. If magma is thick and trapped, pressure can build catastrophically. In some eruptions, expanding gas becomes the primary engine behind the explosion itself. Entire mountains can rupture apart because underground gases suddenly expanded faster than surrounding rock could contain them. That means volcanic eruptions are not driven only by molten rock. They are also driven by trapped pressure trying to escape. And perhaps that helps explain the fifth secret. Some lava is far hotter than most people realize. Many lava flows range between roughly 700 and 1,200 degrees Celsius. At those temperatures, rock glows orange, red, or white against the darkness, like pieces of Earth's mantle exposed directly to the night sky. Ancient humans witnessing eruptions without scientific explanations must have found them almost supernatural. Even today, active lava fields create scenes that barely look real. Entire landscapes pulse with heat. Air shimmers violently above black volcanic rock. Rivers of molten stone slowly consume forests, roads, and coastlines while moving with an eerie calmness. And strangely enough, lava can appear almost alive, which connects to the sixth secret. Some lava flows move like thick liquid, while others barely flow at all. Highly fluid basaltic lava may spread outward in smooth waves resembling glowing water. Other eruptions produce thick lava domes that pile upward slowly around volcanic vents because the material is too viscous to travel far. In some eruptions, lava becomes so thick it can clog volcanic openings, almost like hardened paste inside a pipe. Pressure then builds underneath until another explosive release occurs later. This creates a strange rhythm inside some volcanic systems, periods of blockage followed by violent rupture. And over time, these repeated eruptions shape the volcano itself. That process leads to the seventh secret. Some volcanic landscapes are built from thousands of separate eruptions layered across immense spans of time. A volcano may look permanent from a human perspective, but many mountains are actually temporary structures slowly constructed eruption by eruption. Ash settles, lava cools, new layers form, older sections collapse, rain erodes the surface, fresh magma rises again. Over hundreds of thousands of years, entire volcanic islands can grow out of the ocean, collapse into the sea, and rebuild themselves repeatedly. Hawaii continues expanding even now through ongoing volcanic activity. Iceland is still forming new land. In rare cases, submarine eruptions suddenly create islands where open ocean existed only months earlier. Earth is not merely being damaged by volcanoes. In many places, it is still actively being built by them. And sometimes, lava creates formations so unusual, they almost seem artificial. That is the eighth secret. Certain lava flows form enormous underground tunnels. As fluid lava travels downhill, the outer surface may cool and harden first, while molten rock continues flowing beneath it. Eventually, the eruption stops, leaving behind hollow lava tubes stretching for miles underground. Some are large enough for humans to walk through. Others may exist beneath entire volcanic regions, still mostly unexplored. Scientists have even speculated that lava tubes on the Moon or Mars could someday provide shelter for future human explorers, because thick rock ceilings might protect against radiation and temperature extremes. In that sense, ancient volcanic activity could one day help humans survive on other worlds. But volcanoes also shape life much closer to home, because the ninth secret is that volcanic destruction often creates extraordinary fertility afterward. Fresh volcanic ash contains minerals capable of enriching soil over time. Regions surrounding volcanoes frequently become highly productive for agriculture once conditions stabilize again. This creates one of the oldest contradictions in human history. Volcanoes destroy civilizations, yet humans repeatedly return to live beside them. Naples remains heavily populated near Vesuvius. Millions live around volcanic regions in Indonesia, Japan, Mexico, and the Philippines. Farmers continue planting crops in volcanic soil because the land can become remarkably fertile. People are drawn back not because volcanoes are safe, but because volcanic landscapes often support life unusually well after devastation passes. And maybe that strange cycle between destruction and renewal explains the final secret about magma. Most eruptions humans never witness are happening right now beneath oceans. Deep below the sea, magma continuously rises along underwater ridges and volcanic systems hidden beneath thousands of feet of water. Entire sections of Earth's crust are constantly forming in darkness, where no human eyes can directly observe them. Some submarine eruptions release enough material to alter coastlines. Others produce strange mineral towers around hydrothermal vents, where unusual ecosystems survive without sunlight. And because so much volcanic activity remains underwater, scientists suspect humanity still understands only part of Earth's total volcanic system, which leaves one lingering thought behind all these glowing rivers and hidden magma chambers. The planet beneath human civilization is not cold stone. It is a world of pressure, heat, chemical transformation, and slow movement happening continuously below the surface. Every lava flow, every eruption, every glowing crack opening in the ground is evidence that Earth is still releasing energy from deep within itself. And somewhere tonight, beneath mountains, beneath oceans, and beneath places where millions of people are sleeping peacefully, magma may already be rising silently upward through the dark. Long before modern civilization covered the planet with cities, highways, and electric light, volcanic eruptions were already reshaping human history in ways people at the time could barely understand. Entire coastlines vanished, harvests failed thousands of miles away, the sky itself changed color, and sometimes, without warning, thriving cities simply disappeared beneath ash as if the earth had decided to erase them. What makes historical eruptions so unsettling is not only their violence, but the realization that many people living beside these volcanoes had no idea what they were truly facing until it was too late. Because the first secret about history's most terrifying eruptions is that some ancient civilizations may not have fully understood volcanoes at all. Before geology existed, mountains that smoked or rumbled were often interpreted spiritually. In parts of the ancient Mediterranean, volcanic eruptions were linked to angry gods, imprisoned giants, or gateways into the underworld. Similar beliefs appeared across many cultures living near volcanic regions because there were few other ways to explain why mountains sometimes exploded. And in some cases, those myths may have formed after real disasters so traumatic they survived for generations through oral storytelling. Perhaps no eruption represents this more famously than Mount Vesuvius. That leads to the second secret. Pompeii may have died faster than most people imagine. For centuries, popular imagination pictured the city slowly buried while residents attempted to flee through falling ash. but modern archaeological research suggests many victims may have been killed almost instantly when pyroclastic surges swept through the city. These clouds of superheated gas, ash, and debris moved with terrifying speed. Temperatures likely became lethal within moments. Some studies suggest victims may not even have had time to fully process what was happening before the heat overwhelmed them. And what makes Pompeii especially haunting is how ordinary the city looked just before destruction. People were cooking meals, opening shops, walking streets. Bathhouses were operating normally. Then suddenly, an entire world stopped in place. Even today, the preserved shapes of victims found beneath volcanic ash create one of the strangest feelings in archaeology, not because they look ancient, but because they look human in familiar ways. Curled bodies, families together, people shielding themselves instinctively from forces they could not escape. And yet Vesuvius was not even the most powerful eruption in history. Because the third secret is that some eruptions affected the entire planet. In 1815, Mount Tambora in Indonesia erupted with extraordinary force. The explosion was so large that enormous amounts of ash and sulfur entered the atmosphere, partially blocking sunlight around the world. The following year became known as the Year Without a Summer. Snow reportedly fell during June in parts of North America. Crops failed across regions of Europe. Temperatures dropped unexpectedly. Food shortages spread through multiple countries. Many people living through those strange weather patterns had no idea a volcano on the other side of the world might be connected to their suffering. And that reveals something deeply unsettling about volcanoes. A single eruption can influence regions thousands of miles away from the volcano itself. But Tambora was not alone, because the fourth secret is that volcanic ash clouds can quietly reshape the atmosphere in ways humans barely notice at first. After major eruptions, tiny particles suspended high in the atmosphere scatter sunlight differently. Sunsets become unusually vivid. The sky can appear strangely pale or hazy for months. Some historians and scientists have even debated whether volcanic eruptions influenced the atmosphere visible in certain famous paintings throughout history. There are theories suggesting that unusually colorful sunsets painted by artists in particular eras may have partially reflected real atmospheric conditions following major eruptions. The idea remains debated in some cases, but it reveals how deeply volcanic events can alter the human experience of the world itself. Sometimes, people do not immediately realize they are living through the aftermath of an eruption. And occasionally, the eruption becomes unforgettable for another reason entirely. That brings us to the fifth secret. Krakatoa may have produced the loudest sound in recorded modern history. When the Indonesian volcano erupted in 1883, the explosion was heard thousands of miles away. Reports describe the sound reaching Australia and islands deep into the Indian Ocean. Nearby sailors suffered ruptured eardrums. Pressure waves circled the planet multiple times. Even now, scientists estimate the eruption reached extraordinary acoustic intensity levels, beyond anything most humans have ever experienced. But perhaps even stranger than the sound was what followed. Massive tsunamis spread outward across coastlines. killing tens of thousands of people. Entire villages disappeared beneath waves generated not only by the eruption itself, but by sections of the volcanic island collapsing into the sea. And afterward, the atmosphere changed globally. For months, sunsets around the world reportedly glowed with unusual shades of red and orange as volcanic particles drifted high above Earth. It must have felt almost apocalyptic to people living at the time, which connects to the sixth secret. Some eruptions may have influenced the decline of civilizations. One of the most discussed examples involves the ancient Minoan civilization on the island of Crete. Around the 2nd millennium BCE, the nearby volcanic island of Thera, now known as Santorini, experienced a massive eruption. The explosion devastated surrounding regions and likely generated enormous tsunamis across the eastern Mediterranean. Researchers continue debating exactly how much this event contributed to the weakening of Minoan society. Some believe the eruption severely damaged trade networks and coastal settlements. Others argue the civilization survived longer than earlier theories suggested. But what remains undeniable is that volcanic disasters have repeatedly collided with fragile human systems throughout history, and civilizations built near volcanic regions often faced a difficult trade-off. Volcanic soil could become extremely fertile, yet the same landscapes capable of supporting large populations also carried the possibility of catastrophic destruction. That contradiction appears again and again across history. And sometimes, eruptions vanished almost entirely from human memory. Which leads to the 7th secret. There may have been ancient eruptions far larger than historical records clearly preserve. Ice cores, sediment layers, and geological evidence reveal massive volcanic events long before written history existed. Some eruptions may have darkened skies globally or altered climates for years, yet no detailed human descriptions survived. In some cases, archaeologists and climatologists still debate whether sudden societal changes, migrations, or famines in ancient periods were partially connected to volcanic activity. The evidence is often incomplete, but the possibility itself changes how people view the ancient world. History may contain hidden volcanic disasters humanity only partially remembers. And perhaps even more unsettling is the 8th secret. Some eruptions happened with surprisingly little warning. Modern monitoring systems track earthquakes, gas emissions, swelling ground, and thermal changes around volcanoes. But before modern instruments existed, many populations had little ability to recognize early warning signs. Even today, volcanic systems remain difficult to predict perfectly. Some volcanoes show months of unrest before erupting. Others escalate rapidly. In 1980, Mount St. Helens in Washington state produced one of the most famous eruptions in modern American history. Scientists knew activity was increasing, but the eruption still surprised many observers because the mountain exploded sideways after a massive landslide destabilized the volcano. The blast flattened forests across huge distances within minutes. Entire landscapes looked almost unreal afterward, covered in ash, fallen trees, and silence. And perhaps one of the strangest things about volcanic disasters is how quickly nature eventually returns. That is the ninth secret. Life often comes back faster than humans expect. Following major eruptions, volcanic regions may initially resemble lifeless wastelands. Ash buries vegetation, rivers change course, entire ecosystems collapse. Yet, over time, recovery begins. Microorganisms return first. Plants slowly emerge from cracks in hardened ash. Animals follow. Fresh volcanic minerals enrich soil. In some places, forests eventually regrow over landscapes once considered permanently destroyed. This cycle of destruction, followed by renewal, appears repeatedly throughout volcanic history, almost as if Earth continuously rebuilds over its own scars. And maybe that is why eruptions continue to fascinate humanity, rather than only terrify it. Because the final secret hidden inside history's greatest eruptions is that volcanoes constantly remind civilization how temporary human stability really is. Cities often feel permanent while they are thriving. Empires believe their roads, buildings, economies, and technologies will continue indefinitely. Yet a single eruption can interrupt agriculture, alter weather, collapse infrastructure, darken skies, or force migrations across entire regions. And beneath all modern technology, Earth itself remains the same restless planet that buried Pompeii, shook Krakatoa apart, and dimmed sunlight after Tambora. Even tonight, some volcanoes around the world are quietly releasing gas into the atmosphere. Others are swelling slowly underground. Most will never produce civilization-changing disasters, but history suggests the possibility never fully disappears. Because somewhere beneath the surface right now, pressure may already be building toward the next eruption. Future civilizations will one day study the same way we study the lost worlds of the past. Most people imagine volcanoes as mountains, sharp peaks rising above the landscape, smoke drifting upward, rivers of lava sliding down dark slopes. But the first secret about supervolcanoes is that many of them do not look like volcanoes at all. Some are so enormous that the human mind struggles to recognize them as single geological structures. Forests grow across them. Lakes fill their collapsed centers. Entire highways, towns, and valleys can exist inside them without most people realizing they are standing on top of one of the most destructive forces Earth can produce. Yellowstone is perhaps the most famous example. Millions of visitors travel there each year to see geysers, wildlife, forests, and hot springs. The landscape feels peaceful in many places, almost ancient and untouched. But beneath that calm surface lies a volcanic system so large that earlier eruptions reshaped huge portions of North America. And what makes Yellowstone unsettling is not simply its size. It is the realization that supervolcanoes change the scale of volcanic disasters entirely. A normal volcanic eruption might destroy a city. A supereruption could affect the planet. That is the second secret. Supervolcanoes are not merely bigger volcanoes. They behave differently. In many ordinary eruptions, pressure escapes through a relatively concentrated vent or crater. But supervolcanic systems often involve enormous underground magma reservoirs spread across vast regions beneath Earth's crust. When enough magma accumulates underground, the surface above may eventually collapse inward after eruption, forming giant depressions known as calderas. Some calderas stretch dozens of miles across. From ground level, people often cannot even see the full structure because it is too massive to perceive as one shape. Standing inside certain supervolcanic regions can feel completely normal precisely because the geological system is operating on scales larger than everyday human experience. And that scale becomes even harder to comprehend when considering the third secret. Human civilization has never witnessed a full supereruption in recorded modern history. Scientists study ancient ash layers, mineral deposits, rock formations, and buried volcanic material to reconstruct what these eruptions may have looked like. The evidence suggests some past supereruptions released thousands of times more material than famous eruptions like Mount St. Helens. But because no modern society has directly experienced one, much about their real global effects remains uncertain. Researchers can model climate consequences, crop failures, atmospheric changes, and transportation disruptions, but simulations are still approximations. In other words, humanity understands supervolcanoes mostly through traces left behind by catastrophes no human civilization remembers. And some of those traces are astonishing. Which leads directly to the fourth secret. One ancient eruption may have pushed humanity dangerously close to collapse. Roughly 74,000 years ago, the Toba supereruption occurred in what is now Indonesia. It was one of the largest known eruptions in Earth's recent geological history. For years, some scientists proposed the Toba catastrophe theory, suggesting the eruption triggered a volcanic winter severe enough to dramatically reduce the human population, possibly leaving only a small number of surviving humans worldwide. The theory remains debated. Some genetic studies and climate evidence appear partially consistent with population bottlenecks. Other researchers argue human populations may have been more resilient or regionally protected than earlier theories assumed. But regardless of whether Toba nearly erased humanity, the eruption clearly altered environments across enormous distances. Ash deposits from Toba have been discovered far from the eruption site itself. And perhaps the most unsettling part is realizing that early humans survived events modern civilization has never experienced. That realization becomes heavier with the fifth secret. A supereruption would not need direct lava flows to disrupt modern civilization. Most people instinctively picture destruction happening near the volcano itself. But the broader danger may come from ash and atmospheric effects spreading outward across continents. Fine volcanic ash can damage engines, contaminate water systems, collapse roofs, disrupt agriculture, and interfere with air travel. After relatively modest eruptions in modern times, flights across huge regions have already been cancelled because volcanic ash can destroy jet engines. A true supereruption could create disruptions on scales difficult to fully predict. Global supply chains, food transportation, satellite systems, international trade, and electrical infrastructure all depend on stability modern civilization often takes for granted. And supervolcanoes remind humanity how fragile that stability might actually be, especially because of the sixth secret. Some supervolcanoes may show warning signs for long periods before erupting, but interpreting those signs remains incredibly difficult. Ground uplift, earthquake swarms, changes in gas emissions, hydrothermal disturbances. These can all indicate movement within a volcanic system. Yet, volcanic regions sometimes display unrest for years without leading to catastrophic eruption. Yellowstone itself experiences frequent small earthquakes and geothermal changes, but scientists do not consider this evidence that a supereruption is imminent. In fact, most experts emphasize that a Yellowstone supereruption in the near future is considered unlikely based on current understanding. Still, uncertainty remains part of volcanology because Earth does not always behave consistently. And that uncertainty connects directly to the seventh secret. Some supervolcanic systems may be partially hidden beneath ordinary landscapes. Campi Flegrei, near Naples, Italy, is one example. Unlike dramatic, cone-shaped volcanoes, much of the volcanic system spreads beneath populated regions containing towns, roads, and neighborhoods. The name itself means burning fields. Ancient Romans noticed unusual geothermal activity there long before modern geology existed. Even today, the region continues experiencing gradual ground movement known as bradyseism, where the land slowly rises and falls due to underground volcanic processes. Millions of people live nearby. And perhaps that is what makes supervolcanoes psychologically different from many natural disasters. They often hide in plain sight. No towering peak is required. No constant eruption is necessary. Sometimes, the danger exists beneath landscapes humans no longer instinctively recognize as volcanic. And maybe that invisibility contributes to the eighth secret. Supervolcanoes may influence climate more than almost any other natural disaster. Large eruptions inject sulfur-rich particles high into the atmosphere, where they can reflect sunlight away from Earth's surface. Temperatures may cool globally for months or years, depending on eruption size. Scientists believe ancient eruptions likely contributed to abrupt environmental changes throughout Earth's history. Some researchers even investigate whether repeated volcanic events influenced evolutionary pressures by altering habitats, food supplies, and migration patterns over long timescales. Volcanoes do not merely shape landscapes. At times, they may partially shape the trajectory of life itself. And strangely, the same systems capable of planetary disruption also create some of Earth's most beautiful geothermal environments. That contradiction leads to the ninth secret. Supervolcanic regions often appear peaceful between eruptions. Yellowstone's geysers, hot springs, and colorful thermal pools attract visitors precisely because they are beautiful. Steam rises gently through cold morning air. Wildlife moves through forests above hidden heat systems below. Yet every geothermal feature is evidence of enormous energy still trapped underground. The beauty exists because the system remains active. In some ways, geothermal landscapes feel like pressure escaping slowly enough for humans to witness safely. A reminder that beneath the calm surface, the planet is still releasing heat from deep below. And maybe that is why supervolcanoes continue to fascinate people even more than ordinary eruptions, because they reveal the final secret. Human civilization exists on a planet capable of events far larger than civilization itself. Modern humanity often measures danger through wars, economies, political systems, or technological risks. Yet, supervolcanoes belong to a category of planetary forces operating almost independently of human timelines. Empires rise and disappear, while magma systems slowly evolve underground. Entire civilizations may flourish during periods when volcanic systems remain quiet. Then, perhaps once in tens of thousands of years, Earth releases pressure on a scale almost impossible for humans to emotionally comprehend. And somewhere beneath Yellowstone, beneath Campi Flegrei, beneath ancient calderas hidden around the world, molten rock is still moving slowly through darkness to night. Not racing, not exploding, just gathering heat and pressure deep below a civilization that often forgets how alive the planet beneath it really is. When most people imagine volcanoes, they picture mountains rising into the sky. They imagine smoke drifting above islands, glowing lava rolling down dark slopes, or ash clouds towering over cities. But the first secret about Earth's volcanoes is that most of them are hidden far below the surface of the ocean, in a world almost no human being has ever seen directly. Beneath thousands of feet of dark water, entire volcanic systems are erupting right now in complete silence. No crowds are watching, no cameras are filming, and in many cases, humanity only realizes an eruption happened after instruments detect strange vibrations moving through the sea. That hidden world beneath the oceans may actually be the most volcanically active place on Earth. Because the second secret is that the ocean floor itself is constantly being created. Deep underwater, enormous volcanic ridges stretch across the planet like seams running through Earth's crust. The Mid-Atlantic Ridge alone extends for thousands of miles beneath the Atlantic Ocean, making it part of the longest mountain chain on Earth, even though most people never think about it at all. Along these ridges, tectonic plates slowly pull apart. As they separate, magma rises upward from below, cools against seawater, and forms new crust. This process has likely been happening for hundreds of millions of years. In other words, parts of the ocean floor beneath modern civilization are younger than some dinosaurs once were. And perhaps even stranger, humans discovered this surprisingly recently. For most of history, people knew more about the visible surface of the moon than the volcanic geography hidden beneath Earth's oceans. Which leads directly to the third secret. Some underwater eruptions create entirely new islands. In rare moments, volcanic activity pushes enough material upward to break through the ocean's surface itself. Steam explodes into the air. Ash clouds rise above the sea. And gradually, where open water existed before, new land appears. One of the most famous examples happened near Iceland in 1963 when the island of Surtsey emerged from the Atlantic Ocean after a submarine eruption. Scientists realized immediately that the island offered something extraordinary: the chance to watch an entirely new ecosystem form from the beginning. Over time, seeds arrived, birds landed, plants spread slowly across volcanic rock. Life began colonizing fresh land almost from nothing. It was a reminder that volcanoes do not only destroy landscapes, sometimes they create them. And yet, underwater eruptions can also become incredibly violent. That is the fourth secret. When magma collides with seawater, the interaction can become explosively unstable. Water instantly flashes into steam. Pressure builds rapidly. Fragmented volcanic rock blasts outward beneath the ocean surface. In some eruptions, enormous steam-driven explosions occur even before lava itself becomes visible above water. Scientists call some of these interactions phreatomagmatic eruptions. But what matters more than the terminology is the strange image itself. Fire and water colliding under crushing pressure in total darkness, deep beneath the sea. And sometimes, those eruptions leave behind landscapes so alien they barely resemble Earth at all. Which brings us to the fifth secret. Hydrothermal vents may be some of the strangest places on the entire planet. Near underwater volcanic regions, seawater seeps deep into cracks in Earth's crust, becomes superheated by magma below, and rises back upward carrying dissolved minerals and chemicals. The result is a world of black smokers, towering mineral chimneys, and boiling water emerging from the sea floor in darkness colder than most people can imagine. Yet, despite the extreme conditions, life thrives there. And not just simple life. Entire ecosystems survive around hydrothermal vents without relying on sunlight at all. That discovery shocked scientists when these environments were first explored in the late 20th century, because it challenged one of humanity's deepest assumptions about life itself. For centuries, people believed sunlight formed the foundation of nearly all ecosystems. But organisms near hydrothermal vents survive through chemosynthesis, using chemical energy rather than solar energy. And that possibility opened another unsettling question. If life can exist in darkness around volcanic heat on Earth, could similar environments exist elsewhere in the universe? Some scientists now speculate that icy moons like Europa or Enceladus may contain hidden oceans warmed by geothermal activity beneath thick ice layers. If hydrothermal systems exist there too, entirely alien ecosystems might theoretically survive far below frozen surfaces humans have never reached. Which makes Earth's underwater volcanoes feel less like isolated geological systems and more like windows into how life itself may function across the cosmos. And still, much of the deep ocean remains unexplored. That is the sixth secret. Humanity may know surprisingly little about how many underwater volcanoes actually exist. Researchers estimate there could be millions of submarine volcanic structures scattered across Earth's seafloor. Many remain unmapped in detail. Some have never been directly observed. Even modern sonar mapping has covered only portions of the ocean floor at high resolution. The deep sea hides volcanic mountains taller than skyscrapers, massive calderas, lava plains, and fracture systems stretching across enormous distances. And because the ocean conceals them beneath darkness and pressure, they rarely enter public imagination the way visible volcanoes do. But invisibility does not make them inactive, because the seventh secret is that underwater eruptions can still trigger global consequences. Submarine volcanic collapses may generate tsunamis capable of crossing entire oceans. Some scientists continue studying whether ancient volcanic landslides contributed to massive waves in Earth's past. Even relatively small volcanic disturbances beneath the sea can affect shipping routes, underwater communication systems, fisheries, and coastal environments. And in the modern world, humanity depends heavily on systems hidden beneath oceans, which connects directly to another strange reality. The eighth secret is that submarine volcanoes exist beside the cables carrying much of the world's internet traffic. Thousands of miles of fiber optic cables cross the ocean floor, connecting continents together. These cables carry financial transactions, communication, streaming media, military data, and enormous portions of global internet infrastructure. Most people never think about them. Yet some pass through geologically active regions where earthquakes, underwater landslides, or volcanic activity may damage critical connections. In a strange way, modern civilization has quietly built parts of its digital nervous system across a volcanic planet still reshaping itself beneath the oceans. And sometimes, the ocean reveals evidence of that hidden activity in beautiful ways. That is the ninth secret. Certain underwater eruptions create floating stone. When gas-rich lava cools rapidly in water, it can form lightweight volcanic rock called pumice, filled with tiny air pockets. Massive pumice rafts have occasionally drifted across oceans after eruptions, carrying marine organisms with them over long distances. Satellite images sometimes capture entire floating fields of volcanic rock spreading across the sea like strange gray continents. To sailors in earlier centuries, scenes like that must have felt almost impossible to explain. An ocean suddenly covered in stone. And perhaps the strangest part of all is the final secret. Most underwater volcanic activity happens in complete darkness, far beyond human sight. At deep ocean pressures, sunlight disappears entirely. Temperatures near volcanic vents swing between freezing seawater and near boiling hydrothermal flows. Strange creatures move through clouds of minerals, illuminated only by submersible lights or faint geothermal glow. It is one of the most alien environments on Earth. Yet this hidden volcanic world may actually be more representative of the planet than the dry land humans inhabit. After all, oceans cover most of Earth's surface, and beneath those oceans, tonight, magma continues rising through cracks in the sea floor, exactly as it has for millions of years. New crust is forming. Hidden mountains are growing. Hydrothermal vents are releasing heat into dark water. And somewhere in that vast underwater silence, an eruption may already be happening right now, with no human witness at all. Most people think they understand what a volcano looks like. A mountain, a crater, smoke drifting into the sky, rivers of glowing lava moving slowly down dark slopes. But the deeper scientists explore Earth's volcanic systems, the stranger volcanoes become. Some erupt blue fire at night. Some sit hidden beneath ice sheets. Some spit mud instead of lava. And some create lightning storms so violent they resemble scenes from another planet. The first secret about the world's strangest volcanoes is that volcanoes do not always follow the image humans expect. In Indonesia, on the island of Java, sits Kawah Ijen, a volcanic system famous for something that looks almost supernatural after sunset: blue fire. At night, electric blue flames appear to flow across the dark volcanic landscape like glowing rivers from a science fiction film. For years, photographs of the phenomenon spread across the internet because people assumed the volcano itself was erupting blue lava. But the truth is even stranger. The blue glow comes from sulfuric gases escaping through cracks at extremely high temperatures. When the gases ignite and burn, they create neon blue flames visible against the darkness. Molten sulfur can also flow downhill in glowing streams before cooling into deep red crusts. The result feels less like Earth and more like another world entirely. And perhaps what makes Kawah Ijen so haunting is that miners still work there, carrying heavy baskets of sulfur across toxic volcanic terrain despite dangerous fumes and extreme conditions. Which leads directly to the second secret. Some volcanoes kill silently through gas rather than eruption. In 1986, Lake Nyos in Cameroon became the site of one of the strangest volcanic disasters in modern history. Deep beneath the lake, volcanic gases had slowly accumulated underwater for years. Then suddenly, something triggered a massive release of carbon dioxide. The gas surged outward, invisibly, across nearby villages during the night. Because carbon dioxide is heavier than air, it flowed close to the ground, displacing oxygen as people slept. More than 1,700 people died. There was no lava, no dramatic explosion, no towering ash cloud, only silence. Even now, Lake Nyos remains deeply unsettling because it revealed that volcanic systems can become deadly in ways humans barely notice until it is too late. And sometimes, volcanoes become strange not because of fire, but because of ice. That is the third secret. Some volcanoes exist beneath glaciers and polar ice sheets. In Iceland and Antarctica, volcanic heat rises beneath enormous masses of ice, creating hidden systems where fire and frozen water continuously interact. When eruptions happen under glaciers, the results can become chaotic. Ice melts rapidly. Floods surge outward. Steam explodes upward through cracks in the frozen surface. Iceland has experienced these glacial outburst floods repeatedly throughout history. Entire rivers can suddenly swell with meltwater, carrying ash, rock, and debris from eruptions hidden below the ice. And beneath Antarctica, scientists have identified volcanic systems buried under miles of frozen landscape. The idea itself feels almost impossible. Somewhere under the coldest places on Earth, magma is still moving through darkness. And that strange contrast between fire and ice appears again in another unexpected form. Because the fourth secret is that some volcanoes erupt mud instead of lava. Mud volcanoes exist in places like Azerbaijan, Indonesia, and parts of the Caspian region. Instead of molten rock, these systems release mixtures of mud, gas, water, and sediment from underground pressure zones. Some bubble slowly for years. Others erupt violently enough to ignite fires when methane escapes and catches flame. In 2006, the Lusi mud eruption in Indonesia began flooding nearby communities with hot mud after drilling operations in the area, though scientists still debate exactly what triggered the disaster. The eruption buried villages, displaced thousands of people, and continued for years. It looked less like a traditional volcanic eruption and more like Earth itself dissolving into liquid ground. And perhaps that is what makes strange volcanoes so psychologically disturbing. They challenge people's assumptions about what the planet is supposed to do, especially when the atmosphere itself begins reacting violently. That brings us to the fifth secret. Volcanoes can create their own lightning storms. Inside massive ash plumes, particles collide constantly as they rise through turbulent air. These collisions generate electrical charges that eventually discharge as volcanic lightning. The result can look terrifying. Towering black eruption clouds split open by flashes of white and blue light, while ash rises miles into the sky. Ancient humans, witnessing volcanic lightning without scientific explanations, must have interpreted scenes like this as supernatural events. Even now, footage of volcanic storms often feels unreal because it combines so many elemental forces at once: fire, darkness, electricity, ash, and thunder, all merging into a single event. And sometimes, volcanoes become strange because they refuse to stop erupting. That is the sixth secret. Some volcanoes remain active for decades. Mount Yasur in Vanuatu has reportedly erupted almost continuously for centuries. Stromboli in Italy has produced frequent eruptions for so long that ancient sailors once used its glowing summit as a natural lighthouse. Instead of one catastrophic explosion followed by silence, these volcanoes pulse repeatedly like restless geological engines. Visitors standing near them at night often describe the experience as strangely hypnotic. A deep rumble, a flash of orange light, a brief explosion, then darkness again, over and over. It feels less like watching a mountain and more like standing beside something alive. And some volcanoes create landscapes so unusual they almost erase the line between geology and fantasy. That is the seventh secret. Certain volcanic regions produce lakes so acidic they can dissolve skin, metal, and rock. At Kawah Ijen, the crater lake contains highly acidic water, colored bright turquoise by dissolved minerals and volcanic chemistry. The color looks beautiful from above, almost artificial in its intensity. Yet, beneath that beauty lies extreme chemical danger. Similar acidic volcanic lakes exist elsewhere around the world, creating environments where water itself becomes hostile to life. It is another reminder that volcanic systems are not merely hot. They are chemically active in ways that transform entire landscapes. And occasionally, those transformations create rocks that behave strangely enough to seem impossible. Which leads to the 8th secret. Some volcanic rocks can float on water. Pumice forms when gas-rich lava cools rapidly, trapping countless tiny air pockets inside hardened stone. The result is rock light enough to float across oceans for months or even years. After major eruptions, enormous pumice rafts sometimes drift across the sea, carrying marine organisms with them. Ancient sailors encountering floating fields of stone must have found the sight deeply confusing. An ocean covered in rock should not exist, yet volcanoes create it anyway. And perhaps no volcanic landscape feels stranger than the places humans can barely approach at all. That is the 9th secret. Some volcanoes are so remote and hostile that scientists still struggle to study them directly. Deep sea volcanoes erupt in darkness beneath crushing pressure. Antarctic volcanic systems hide under ice sheets. Certain volcanic islands remain dangerous because of toxic gas emissions, unstable terrain, or ongoing eruptions. Even with satellites and modern instruments, parts of Earth's volcanic world remain surprisingly unexplored. There are likely volcanic systems humans still know very little about. And maybe that mystery is what makes volcanoes endlessly fascinating. Because the final secret is that the stranger volcanoes become, the more they reveal how unfamiliar Earth still is. Human civilization often treats the planet as fully mapped and understood. Roads cross continents. Satellites circle overhead. Cities glow across the night side of Earth. Yet volcanoes continue exposing environments that feel ancient, alien, and unpredictable. Blue fire burns in darkness. Acid lakes shimmer beneath toxic clouds. Lightning erupts inside ash storms. Mud floods entire landscapes. Hidden magma moves beneath glaciers and oceans beyond human sight. And somewhere tonight, in a remote volcanic region far from cities and cameras, Earth may already be creating another phenomenon strange enough to remind humanity how little of this planet we truly understand. At first glance, volcanoes seem like the opposite of life. They bury forests beneath ash. They poison rivers with toxic gas. They destroy cities, blacken skies, and erase entire ecosystems in a matter of hours. Few places on Earth appear more hostile than fresh volcanic terrain still radiating heat into the air. And yet, the first secret about volcanoes and life is that many scientists believe life itself may owe part of its existence to volcanic activity. Long before forests, oceans filled with fish, or even oxygen-rich skies existed, early Earth was a violent volcanic world. Massive eruptions shaped the surface continuously. Lava covered huge regions. The atmosphere looked nothing like the one humans breathe today. But those ancient eruptions may also have released enormous amounts of water vapor, carbon dioxide, nitrogen, and other gases into the young atmosphere. Without volcanic outgassing, Earth might have remained a far colder and drier world. In some ways, volcanoes may have helped build the environmental conditions life eventually needed. And that possibility becomes even stranger when scientists look deep beneath the oceans. Because the second secret is that life may have begun near underwater volcanic vents. Far below the surface of the sea, hydrothermal vents release mineral-rich, superheated water from Earth's crust into dark ocean environments untouched by sunlight. Around these vents, strange ecosystems thrive using chemical energy rather than solar energy. Some researchers believe environments like these may resemble the conditions where the earliest life on Earth first emerged billions of years ago. The theory remains actively studied and debated, but it carries enormous implications. If life can begin around volcanic chemistry in complete darkness, then sunlight may not be the only path to biology in the universe. And perhaps more importantly, it changes how people think about volcanoes themselves. Instead of being purely destructive, volcanic systems become places where energy, chemistry, heat, minerals, and water interact continuously. Exactly the ingredients many origin of life theories consider essential. And once life appears, volcanoes continue shaping it in unexpected ways. That leads to the third secret. Volcanic ash can eventually create some of the most fertile soil on Earth. At first, fresh ash appears lifeless. Gray landscapes stretch beneath silent skies. Rivers clog with debris. Entire forests vanish beneath layers of pulverized rock. Yet, over time, weather and biological processes break volcanic material down into nutrient-rich soil containing minerals plants need to grow. This is why regions surrounding volcanoes often become densely populated despite the danger. From Indonesia to Italy to parts of Central America, volcanic landscapes frequently support extremely productive agriculture. People return again and again because the same eruptions capable of destroying crops can later create unusually fertile land. It is one of Earth's oldest contradictions. Life flourishes beside the forces capable of wiping it away. And sometimes, life returns astonishingly fast. That is the fourth secret. Nature often recovers from eruptions more quickly than humans expect. After Mount St. Helens erupted in 1980, parts of the surrounding landscape looked permanently devastated. Entire forests were flattened. Ash buried lakes and valleys. Large areas appeared almost lunar in the immediate aftermath. Yet within years, scientists began documenting surprising ecological recovery. Plants emerged from beneath ash layers. Insects returned. Animals slowly recolonized damaged habitats. Some ecosystems adapted in ways researchers had not predicted. The recovery was not magical or immediate. Many regions remained heavily altered. But life repeatedly demonstrated resilience, even after enormous destruction. And perhaps that resilience exists because living organisms have evolved alongside volcanic instability for hundreds of millions of years. Which brings us to the fifth secret. Some organisms survive in environments humans would consider impossible. Around volcanic vents, acidic springs, geothermal pools, and deep underground heat systems, scientists have discovered extremophiles, organisms capable of surviving extreme temperatures, acidity, pressure, or chemical conditions. Some microbes live in water hot enough to severely burn human skin. Others survive near highly acidic volcanic lakes. These organisms matter because they expand humanity's understanding of where life can exist. If microbes can survive in volcanic darkness beneath Earth's oceans or inside geothermal systems underground, then perhaps life elsewhere in the universe could survive in similarly extreme environments. Mars, Europa, Enceladus, worlds once dismissed as lifeless, now seem slightly less impossible when viewed through the lens of volcanic biology. And volcanoes themselves may continue influencing climate and evolution in ways humanity still struggles to fully understand. That is the sixth secret. Large eruptions may have altered the course of evolution more than once. Throughout Earth's history, volcanic activity has repeatedly changed atmospheric conditions, temperatures, ocean chemistry, and ecosystems. Some scientists investigate whether massive volcanic provinces, enormous, long-lasting eruptions covering vast regions in lava, contributed to certain extinction events in the distant past. The evidence is complex and still debated in many cases. Ancient extinctions rarely have one simple cause. Asteroid impacts, climate shifts, ocean changes, and volcanic activity may all interact together. But what remains clear is that volcanoes have repeatedly shaped the environmental conditions life evolved within. Entire species rose and disappeared while Earth's volcanic systems continued operating beneath them. And strangely enough, some volcanic landscapes eventually become places of extraordinary biodiversity. That is the seventh secret. Volcanic islands often evolve unique ecosystems found nowhere else on Earth. The Galapagos Islands, Hawaii, Iceland, and other volcanic island chains became natural laboratories for evolution because isolation allowed species to adapt independently over long periods of time. Birds, reptiles, insects, and plants evolved differently on these islands than their relatives elsewhere. Charles Darwin's observations in the Galapagos eventually contributed to ideas that transformed biology forever. And all of it existed because volcanic activity built islands rising from the sea. In that sense, volcanoes do not simply influence life. Sometimes they create entirely new worlds for life to evolve upon. And perhaps nowhere does that relationship feel stranger than in places where humans themselves depend on volcanic systems directly. That is the eighth secret. Millions of people rely on volcanic regions for survival. Geothermal energy heats homes and powers cities in countries like Iceland. Volcanic soils support agriculture, feeding enormous populations across Asia, South America, and Africa. Hot springs shaped trade routes, settlements, and cultural traditions for thousands of years. Even modern tourism economies often depend heavily on volcanic landscapes. People are drawn toward geothermal regions despite the risks because volcanic systems continuously provide resources, fertility, energy, and water. Human civilization itself has quietly adapted around volcanic activity more deeply than many people realize. And still, volcanoes never become fully predictable. Which leads to the ninth secret. Life near volcanoes always exists beside uncertainty. Entire generations may grow up safely beside dormant mountains. Forests return, cities expand, farms spread across old lava flows. Then, suddenly, after decades or centuries of quiet, the Earth changes again. This unpredictability creates a strange psychological relationship between humans and volcanoes. Fear alone does not explain why people remain. Volcanic landscapes are often beautiful. The soil is fertile. The geothermal energy is valuable. The scenery attracts people. And, over time, danger becomes part of the background of ordinary life. Perhaps this is why volcanoes appear so often in mythology, religion, and storytelling across cultures. Humans have always sensed something deeply powerful about living beside a mountain, capable of changing the world overnight. And maybe that feeling connects to the final secret. Volcanoes reveal that destruction and creation are often inseparable on Earth. The same eruption that destroys a forest may later enrich the soil where another forest grows. The same geothermal heat that creates toxic gas may also support ecosystems in darkness. The same volcanic chemistry that once made Earth violent and unstable may have helped life emerge in the first place. In human thinking, destruction and creation are usually treated as opposites. But volcanic systems blur that line constantly. And somewhere tonight, beneath forests, beneath oceans, beneath islands glowing faintly with geothermal heat, Earth is still producing the same volcanic energy that may have helped shape life from the very beginning. Not peacefully, not safely, but continuously. For most of human history, volcanic eruptions seemed almost random. A mountain that had stood silent for generations would suddenly begin shaking. Smoke would rise into the sky, the ground would split open, and within hours or days, entire landscapes could disappear beneath ash and fire. To ancient civilizations, it must have felt as though volcanoes woke up without warning. But the first secret about volcanic eruptions is that the Earth often does send warnings before a volcano awakens. The problem is that those warnings are rarely simple. Modern scientists spend their lives studying tiny changes most people would never notice. Subtle vibrations beneath the ground, invisible gases escaping through cracks, slight swelling in the landscape measured from satellites orbiting hundreds of miles overhead. Because before a volcano erupts, the planet itself often begins behaving differently. And one of the earliest signs can be surprisingly small. That is the second secret. Some eruptions begin with earthquakes too weak for humans to feel. As magma moves underground, it forces its way through rock, opening fractures and shifting pressure deep beneath the surface. This movement creates swarms of tiny earthquakes called volcanic tremors. To scientists monitoring instruments nearby, these tremors can resemble whispers from underground systems beginning to wake. Sometimes, the earthquakes remain minor for weeks or months. Other times, they escalate rapidly. And what makes volcanic tremors unsettling is that they do not always behave predictably. Some volcanoes produce intense seismic activity without erupting. Others remain relatively quiet until shortly before explosion. Earth is sending signals, but humanity is still learning how to interpret them correctly. And sometimes, the land itself begins to move. That is the third secret. A volcano can slowly inflate like a living thing. As magma accumulates underground, pressure may push the surface upward by inches or even feet over time. In some volcanic regions, entire sections of landscape rise so gradually humans cannot detect the change directly, but satellites can. Using radar measurements from space, scientists now track subtle deformations across volcanic systems with astonishing precision. Mountains expand, calderas swell, valleys shift upward almost invisibly. Yellowstone, Campi Flegrei, and other volcanic regions have all shown periods of measurable uplift connected to underground geological activity. Yet even this warning sign remains uncertain. Sometimes the ground rises and later settles again without eruption. Sometimes pressure escapes harmlessly. And sometimes the opposite happens. An eruption arrives faster than expected, which leads to another hidden signal. The fourth secret is that volcanoes often change the chemistry of the air before erupting. As magma rises closer to the surface, gases trapped underground begin escaping more easily through vents, cracks, lakes, and geothermal systems. Sulfur dioxide levels may increase. Carbon dioxide emissions may shift. Steam vents can grow stronger or hotter. Scientists constantly monitor these gases because they provide clues about what may be happening deep below the surface. But volcanic gases carry their own strange uncertainty. Some volcanoes release large amounts of gas without major eruption. Others remain deceptively quiet. And in rare cases, invisible gases themselves become deadly. Carbon dioxide pooling in low areas near volcanic systems can silently displace oxygen. Sulfur-rich emissions can poison water or damage lungs long before lava ever appears. The Earth is communicating constantly, just not in ways humans evolved to naturally understand. And perhaps that is why people continue searching for older, more instinctive warning signs. That is the fifth secret. For centuries, humans have wondered whether animals sense eruptions before people do. Stories appear repeatedly throughout history. Snakes abandoning burrows before earthquakes. Birds suddenly disappearing from volcanic regions. Dogs becoming restless. Livestock behaving strangely. Even today, reports occasionally emerge describing unusual animal behavior before eruptions. Scientists remain cautious about these claims because reliable evidence is difficult to confirm consistently. Animals react to many environmental changes unrelated to volcanoes. Still, some researchers suspect certain species may detect vibrations, gas changes, magnetic shifts, or low-frequency sounds humans cannot perceive easily. The idea remains controversial in many cases, but it reveals something fascinating about volcanic prediction itself. Humanity is still searching for ways to sense what the Earth is doing beneath the surface, and sometimes the warnings become visible even from far away. That brings us to the sixth secret. Thermal cameras can reveal hidden heat before eruptions begin. Modern satellites and drones now monitor volcanic systems across the planet using infrared imaging capable of detecting subtle temperature changes invisible to human eyes. A hillside warming unexpectedly. Snow melting faster near volcanic vents. Hot springs changing temperature. entire geothermal systems becoming more active. To volcanologists, these heat patterns may provide clues that magma is rising upward underground. Yet volcanoes remain frustratingly inconsistent. Some heat signatures fade without eruption. Others appear suddenly. And in remote regions, dangerous volcanic systems may still remain poorly monitored altogether, especially beneath oceans or isolated mountain ranges where instruments are difficult to maintain, which creates a deeply uncomfortable reality. Despite modern technology, humans still cannot predict eruptions with complete certainty. That is the seventh secret. Volcanology is often about probabilities rather than exact predictions. Scientists can estimate risk levels. They can identify increasing activity. They can recommend evacuations based on changing conditions. But predicting the exact moment a volcano will erupt remains extraordinarily difficult. Earth's underground systems are simply too complex. Magma chambers vary in size and structure. Pressure moves through fractures unpredictably. Gas escapes unevenly. Rock strength changes from place to place. Even volcanoes themselves behave differently from one eruption cycle to another. This uncertainty creates enormous pressure for scientists making public safety decisions. Evacuate too early, and communities may stop trusting future warnings. Wait too long, and lives may be lost. And history contains examples of both tragedies and successes shaped by those decisions. Which leads directly to the eighth secret. Some eruptions have been survived because warnings were recognized in time. In 1991, Mount Pinatubo in the Philippines erupted in one of the largest volcanic events of the 20th century. Scientists monitoring earthquakes, gas emissions, and ground deformation recognized signs of escalating danger and helped coordinate large evacuations. Thousands of lives were likely saved because the warnings were taken seriously. Yet, even during successful evacuations, uncertainty remained enormous. No one could know exactly how large the eruption would become. And perhaps that uncertainty is what makes volcanoes psychologically different from storms or floods. A volcano can appear calm right until the moment it is not, which is why dormant volcanoes often create a false sense of permanence. That is the ninth secret. The longer a volcano sleeps, the easier it becomes for humans to forget it is alive. Cities expand near volcanic slopes. Forests cover ancient lava flows. Roads, schools, farms, and neighborhoods spread across old eruption zones. Entire generations grow up without witnessing major activity. Eventually, the volcano begins to feel like scenery rather than a threat. Yet, geological timescales are vastly longer than human memory. A volcano quiet for centuries may still remain active beneath the surface. And when signs of unrest finally appear again, modern civilization often struggles emotionally with the realization that the landscape was never truly stable at all. Perhaps this is why volcanic monitoring feels almost philosophical as much as scientific, because the final secret is that humanity may never completely remove uncertainty from living on an active planet. Technology improves constantly. Satellites watch from orbit. Seismic networks listen underground. Gas sensors track invisible emissions. Artificial intelligence now helps analyze patterns across volcanic systems. And still, deep beneath the crust, magma moves through darkness, mostly beyond direct human observation. The Earth gives signals: tiny earthquakes, swelling ground, heat, gas, strange chemical shifts. But those signals rarely form a simple message. Instead, volcanologists piece together fragments of evidence while the planet continues changing beneath them. And somewhere tonight, beneath a mountain that appears perfectly calm beneath the stars, new pressure may already be building slowly underground, sending signals into the earth that only instruments and perhaps a few restless animals can sense at all. For most of human history, volcanoes felt uniquely tied to Earth. Mountains erupted here, lava flowed here, ash darkened skies here. Fire rising from the ground seemed like something deeply connected to this planet alone. But the first secret about volcanoes in space is that Earth may not even contain the most extreme volcanoes in the solar system. Far beyond our atmosphere, on frozen moons and silent planets drifting through darkness, entire volcanic worlds exist that make Earth's eruptions seem almost ordinary. And perhaps nowhere feels more unreal than Mars. Because the second secret is that Mars contains the largest volcano ever discovered. Olympus Mons rises so high above the Martian surface that it barely resembles a mountain in the way humans normally imagine one. At roughly 13 to 16 miles tall, depending on how it is measured, it towers far above Mount Everest. Its base stretches across hundreds of miles. A person standing near it on the surface of Mars might not even realize they were beside a volcano at all, because the slopes rise so gradually across such enormous distances. Scientists believe Olympus Mons became possible partly because Mars lacks active plate tectonics like Earth. On our planet, tectonic plates slowly move volcanic hotspots over time, spreading eruptions across chains like Hawaii. Mars appears to have remained far more stationary. As magma repeatedly rose through the same location over immense spans of time, the volcano continued building upward, layer after layer. And perhaps the strangest part is that parts of Mars may still retain underground heat today, which leads to the third secret. Some scientists believe certain Martian volcanic regions could have remained active far more recently than people once assumed. Earlier generations often imagined Mars as a completely dead planet, frozen, silent, geologically inactive. But modern spacecraft observations have complicated that image. Certain lava flows appear younger than expected in geological terms. Some volcanic features may have formed surprisingly recently compared to the planet's ancient history. There is no confirmed modern eruption happening on Mars today, but the possibility that volcanic heat still lingers beneath the surface changes how scientists think about the planet. Because wherever heat, chemistry, and underground water may coexist, questions about habitability begin appearing almost automatically. And Mars is only the beginning. That is the fourth secret. The most volcanically active world in the solar system is not Earth. It is Io, one of Jupiter's moons. Io is a place of constant geological violence. Massive eruptions blast material hundreds of miles above the surface. Lava lakes glow across a landscape covered in sulfur, ash, and frozen volcanic plains. The moon looks almost diseased from orbit. Yellow, orange, black, and red patterns spread across a world continuously torn apart by tidal forces from Jupiter's immense gravity. Unlike Earth, where internal heat comes partly from radioactive decay and leftover planetary formation energy, Io is heated intensely by gravitational stress. Jupiter's gravity stretches and compresses the moon repeatedly as it orbits, generating enormous internal friction. In other words, gravity itself may be fueling parts of Io's volcanic nightmare. And perhaps that reveals something unsettling about volcanoes in space. They are not limited to Earth-like worlds at all, which connects directly to the fifth secret. Some volcanoes in space erupt ice instead of lava. Scientists call them cryovolcanoes. On certain icy moons and distant bodies in the outer solar system, extremely cold substances like water, ammonia, or methane may erupt from below the surface the way molten rock erupts on Earth. Instead of rivers of fire, these worlds may release slushy mixtures of ice and chemicals into freezing darkness. Enceladus, a moon of Saturn, famously sprays enormous plumes of water vapor and ice particles through cracks near its south pole. Europa, one of Jupiter's moons, may contain a hidden global ocean beneath thick ice. The exact mechanisms remain actively studied, but if cryovolcanism truly operates there, it means volcanism itself is broader and stranger than humans once imagined. Volcanoes are not simply about lava. They are about internal worlds trying to release energy outward. And in some cases, those hidden internal worlds may contain oceans. That leads directly to the sixth secret. Volcanic heat may help keep alien oceans liquid beneath frozen surfaces. Europa and Enceladus both appear to contain subsurface oceans beneath thick outer ice shells. Scientists suspect tidal heating and possible geothermal activity below may help prevent those oceans from freezing solid. And this matters for one enormous reason. Liquid water plus geothermal chemistry creates conditions many scientists consider potentially favorable for life. No one knows whether life exists in those hidden oceans. There is no proof. But Earth's own hydrothermal vent ecosystems demonstrate that life can survive in darkness around volcanic heat without sunlight. Which means some of the most promising places to search for extraterrestrial life may actually be volcanic environments hidden beneath ice. And suddenly, volcanoes stop feeling like isolated geological curiosities. They become part of one of humanity's biggest questions. How common could life be in the universe? And perhaps even more fascinating is the seventh secret. Volcanoes may reveal whether a world is still geologically alive. When scientists search distant planets and moons for signs of volcanic activity, they are often searching for evidence that internal energy still exists below the surface. A volcanically active world is still changing. still generating heat, still cycling material between interior and exterior environments. Earth's active geology may actually be one reason the planet remained habitable for so long. Plate tectonics and volcanic outgassing help regulate atmospheric chemistry over geological time. Mars, by contrast, appears far quieter today. Its interior cooled faster, its magnetic field weakened. Much of its atmosphere disappeared. And perhaps volcanic decline played some role in transforming Mars from a wetter ancient world into the frozen desert humans see now. Though many details remain uncertain, the comparison reveals how deeply volcanism may influence planetary evolution itself. And sometimes those distant volcanic worlds create landscapes almost impossible to emotionally comprehend. That is the eighth secret. Some volcanic environments in space may be more extreme than anything Earth has ever experienced. Imagine lava fountains erupting beneath black skies without breathable air, sulfur snow falling across frozen plains, ice volcanoes releasing vapor into space itself, lava flows stretching across landscapes untouched for millions of years. No forests, no oceans, no human sound. Only geology operating in total cosmic silence. Even Earth's strangest volcanic regions still feel connected to life. But many volcanic worlds in space feel ancient in a colder, lonelier way. And perhaps that loneliness explains another strange reality. That is the ninth secret. Humans understand many extraterrestrial volcanoes only through distant robotic eyes. No person has ever stood beside Olympus Mons. No human has watched an eruption on Io directly from the surface. Everything humanity knows about these worlds comes through orbiters, probes, telescopes, and remote sensing instruments. Images travel across millions or billions of miles before reaching Earth. Scientists analyze heat signatures, surface changes, gas plumes, and gravitational data, trying to reconstruct environments no human has physically experienced. In a strange way, studying space volcanoes resembles archaeology mixed with imagination. Humanity pieces together clues from distant worlds, while knowing the full reality may feel even stranger than current theories suggest. And maybe that uncertainty is what makes volcanic worlds in space so fascinating. Because the final secret is that volcanoes may be one of the universe's most common languages. Wherever worlds contain internal heat, pressure, gravity, chemistry, and time, volcanism may emerge in some form. Rock erupts, ice erupts, gas escapes. Landscapes reshape themselves slowly in darkness. From Earth to Mars, from Io to distant icy moons, volcanic systems appear again and again across the solar system, like evidence that planets are not static objects drifting silently through space. They are active worlds, restless worlds, and somewhere tonight, far beyond Earth's atmosphere, on a moon orbiting a distant giant planet, beneath a sky filled with stars no human will ever see in person, another eruption may already be rising silently into the cosmic dark. For thousands of years, volcanoes shaped human history from a distance. Ancient cities disappeared beneath ash. Entire civilizations feared mountains they could not control. Eruptions changed climates, darkened skies, and reminded humanity that the ground beneath civilization was never truly stable. But the first secret about the future of volcanoes is that modern humanity may now be more connected to volcanic systems than any civilization before it. Not because volcanoes are becoming more active, but because civilization itself has become more interconnected, more dependent on fragile global systems, and more vulnerable to disruptions spreading across the entire planet. A major eruption today would not only threaten nearby towns, it could ripple through airlines, internet infrastructure, agriculture, shipping routes, power systems, financial markets, and supply chains linking continents together. And in some ways, that interconnected vulnerability changes the meaning of volcanic disaster entirely. Because the second secret is that volcanic ash may be one of the greatest hidden threats to modern technology. Most people think of lava first, but fine volcanic ash behaves differently. Tiny abrasive particles can drift high into the atmosphere and travel enormous distances. For aircraft, this becomes especially dangerous because ash can melt inside jet engines, damage turbines, block sensors, and reduce visibility. In 2010, the eruption of Eyjafjallajökull in Iceland caused widespread flight cancellations across Europe, despite being relatively modest compared to history's largest eruptions. Millions of travelers were affected. Economic losses spread far beyond Iceland itself, and the eruption revealed something modern civilization rarely thinks about. A volcanic system in one remote region can interrupt transportation across an entire continent. And aviation is only the beginning. That leads directly to the third secret. Modern civilization quietly depends on infrastructure crossing volcanic regions beneath oceans. Fiber optic cables carrying enormous portions of the world's internet traffic stretch across the seafloor. Shipping routes pass near tectonically active zones. Coastal cities concentrate millions of people near volcanic belts because fertile land and trade opportunities historically attracted settlement there. Humanity built global civilization on a geologically active planet. Most of the time, that reality fades into the background. Then, occasionally, Earth reminds people it never stopped moving. And perhaps nowhere does that tension feel stranger than in the way humans continue living beside volcanoes despite fully understanding the danger. That is the fourth secret. Millions of people may knowingly accept volcanic risk because volcanic regions offer extraordinary advantages. The soil is fertile. Geothermal energy provides power. Tourism creates economic opportunity. Water systems often flourish near volcanic mountains. Entire cultures and economies grew around volcanic landscapes long before modern hazard maps existed. Today, cities near Vesuvius, Mount Fuji, Popocatépetl, and many other volcanic systems continue expanding despite scientific awareness of potential danger. It is not ignorance. It is a calculation humanity has repeated throughout history. The benefits of living near volcanoes often feel immediate. The disaster may feel distant, until suddenly it is not. And yet, modern science is improving humanity's ability to prepare. That is the fifth secret. Volcanologists now monitor Earth more closely than ever before. Satellites track ground deformation from space. Gas sensors measure subtle chemical changes. Seismic networks detect tiny underground earthquakes. Artificial intelligence increasingly helps analyze enormous streams of volcanic data, looking for patterns humans might miss. Some scientists even hope machine learning may eventually improve eruption forecasting by identifying complex relationships between signals across multiple volcanic systems. But even with advanced technology, prediction remains deeply difficult. Earth does not follow simple rules consistently enough. Every volcano behaves differently, and that uncertainty may never disappear completely, which creates another strange possibility for the future. That is the sixth secret. Humanity may eventually attempt to engineer ways to reduce volcanic risk. At the moment, large-scale volcanic control remains mostly theoretical. Humans cannot stop supereruptions or redirect massive magma systems. Still, smaller experiments already exist. In Iceland and Hawaii, efforts have occasionally been made to slow lava flows using barriers, cooling methods, or diversion strategies. Most had limited success. But the idea itself reveals something fascinating about modern civilization. For most of history, volcanoes represented unstoppable natural forces. Now humans at least imagine the possibility of influencing them, even slightly. Whether future technologies could meaningfully alter volcanic hazards on larger scales remains highly uncertain. But history suggests humanity rarely stops trying to control dangerous environments once enough technology exists. And perhaps future generations may rely on volcanoes more deeply rather than less. That is the seventh secret. Volcanic energy may become increasingly important in a changing world. Geothermal energy taps into Earth's internal heat to generate electricity and provide heating. Countries like Iceland already depend heavily on geothermal systems linked to volcanic activity. Unlike fossil fuels, geothermal energy does not rely on burning carbon-based resources continuously. As humanity searches for long-term energy solutions, volcanic regions may become even more valuable. Yet this creates another paradox. The same underground systems capable of powering cities also remain geologically unstable. In some ways, future civilization may become increasingly dependent on carefully managed volcanic landscapes. And perhaps nowhere is humanity's future relationship with volcanoes more emotionally complicated than around supervolcanoes. That is the eighth secret. Modern civilization has never experienced a true supereruption. Scientists model possible consequences constantly: climate disruption, agricultural collapse, transportation failure, ash contamination, economic instability. But models remain models. No modern government, technological system, or global economy has ever been tested against a full-scale supereruption scenario. Fortunately, experts emphasize that these events are extremely rare on human timescales. Still, rarity does not equal impossibility. And perhaps what unsettles people most about supervolcanoes is not only their destructive potential, but the realization that humanity cannot fully prevent them. There are some planetary forces civilization still mostly survives rather than controls, and volcanoes may always belong partly to that category, especially because of the ninth secret. Climate change and volcanism may interact in ways scientists are still studying. Volcanic eruptions can temporarily cool parts of Earth by injecting reflective particles into the atmosphere. Meanwhile, melting glaciers caused by warming temperatures may slightly alter pressure on Earth's crust in some volcanic regions. Researchers continue investigating whether long-term climate shifts could influence volcanic behavior indirectly over geological timescales. The relationships remain complex and far from fully understood, but the broader pattern is clear. Earth systems are interconnected. Atmosphere, oceans, tectonics, glaciers, ecosystems, and human civilization all influence one another in ways far more tangled than earlier generations imagined. And perhaps that realization leads to the final secret about humanity's future with volcanoes. No matter how advanced civilization becomes, humans will still live on a restless planet. Cities may grow taller. Technology may become smarter. Artificial intelligence may monitor volcanic systems continuously from orbit. Future humans may build colonies on other worlds with volcanoes of their own. And still, beneath every civilization, Earth's interior will continue moving slowly through darkness, exactly as it has for billions of years. Magma will rise, pressure will build. Mountains will sleep for centuries before waking again. Some eruptions will pass quietly. Others may alter history. And somewhere tonight, while millions of people sleep beneath electric lights, believing the modern world feels permanent, deep below the crust, the same ancient volcanic forces that shaped the earliest Earth are still active, silent, patient, and very far from finished. Thanks for spending this time exploring the hidden world of volcanoes with me tonight. If you enjoyed this relaxing journey through Earth's greatest mysteries, don't forget to subscribe for more cinematic documentaries like this. Wherever you are in the world tonight, I hope you have a peaceful evening, a calm night ahead, and I'll see you again in the next journey.